Hello everyone, welcome to Pepcoding. So in this video today we are going to discuss a question, that is word search. So what is given in this question, that is we are given with an m into n size of board of characters and a list of strings of words. So let's see what is this input actually telling us. It is telling us that we will be provided with some size of a board, or we can say it as a matrix, and then we will be provided with some random strings, right? And now what we have to return? We have to return all the words present on the board. So there are some of these words provided to us. These are the valid words, right? So we have to find out that out of all these words which are present on this board, right? We have to find out that out of all these words which of the words are present on this board, and we have to return it, right? But now there is another constant that is telling us that word must be made from letters subsequently adjacent cells, right? So we have to return only those words that are made with subsequent adjacent sides, right? And then where adjacent cells are horizontally or vertically neighboring. Yes, there is an important point. This is telling us that the words or the string that we are forming from the characters that are present on the board should be neighbors to each other, right? Should be connected to each other. The same letter cell may not be used more than once in a word. This is another constant. It is telling us that if a word, let's say here, let's say if we have these two words, eat and eat at, that might be present in this board, then we have to take, if we use this eat, and this eat at is also starting or is also using this same eat, then we cannot form this eat at, that is we cannot form the word starting with e that is being used here also. Okay, so I'll just try to explain you what actually it is saying. Let's say this is our board, like I have created. Let's say what actually that statement was meaning. It was meaning that, let's say there is something like this EAT, right? Or let's say there is an EAT, and there is something like this, right? Let's say, let's write it with some another color, right? And there are some, let's say random words, let's say egg and A B C D E, or let's say F G H I K L Z Y, anything, right? So what are the valid words right here, right now? What are the valid words here? This is one valid word, and this eat at is also a valid word according to the given question. Let's say if there was two valid words given to us, that is eat and eat at, then, and they are aligned something like this, then we cannot use this eat for this eat at. Why? Because it is having the character, the position of that character that is already being used, right? So with this, I hope it is clear to you all. Now let's move on to our question. What actually it is telling us, that we have to find out something like this. Sorry, we are provided with something, some matrix like this, and we have to find out all the valid strings that can be present, all the valid strings given here that are present in this matrix, given matrix, right? So just by seeing to looking towards the question, we know that there is a problem of recursion and backtracking, right? There is a problem of DFS. So what we are going to do, we are going to start from this position, right? From O, we are going to start from O, and we are going to do what? We are going to, it is already told to us that we have to look for the adjacent cells, that is neighboring cells. So we have to make some calls, that is calls to our adjacent neighbors, that is top, left, sorry, right, down and left, right? These are the possible directions in which we can go. And now we have to form a word, and we have to store that in, let's say we have to store it somewhere. Let's say our answer, like something, our answer is created ABC, we have to store it like something this. and EFG, and then we have to return this. We have to do this. So this is a simple problem of recursion and backtracking, we know that, right? But now, instead of traveling again and again, let's say first I am at O, then I am at A. From this A, I am going to make 4 calls, right? Uh, without knowing that this if this A is being included in my given valid strings or not, right? I'm going to just go and make some calls, keeping A as the head node, right? That is not going to make sense, like it is going to be more time consuming. So at that particular point of time, we use the data structure called as tries, right? How tries help us? It reduces our time. Let's see, I'll just show you what we can do in tries. Using tries, what we can do, we'll just create a root node, head node, and we'll store these strings. That is, we'll store all these strings. Sorry, we'll be storing all these strings in this try. That is, we know that this try has a 26 character array which start from A to Z, right? And this stores what? Any letter or any string or anything, any character present in this as its child, it is going to store it as present and others as not null, or others as null, right? So what we are going to do, actually, we are going to first, let's go step by step. We are going to store this O A T H, right? What this H tells us that this is an end of the string. So I'll just give you a recall of tries. At this particular head node or at this parent node, root node, what is going to be stored? There is going to be stored something for O, that is O is only null, others are O is only not null, others are null, which means that currently for this one string of try, that is try or the root node consisting of one child, only one child. Here for this root node there is only one child, so consisting of one child, O is present. For this O, another one, it is also having one child, that is of A. This A is having a one child of T, and others are null, right? Others are null. And this T is having a child as H, and this H is not having any child, but this means that this is the end. This is the end of the string. So there is also another thing that we will be maintaining, or we maintain, that is end boolean kind of thing, boolean type of data that tells us that if this is the end of the string or not. So currently by default it is going to be false everywhere, right? And at the end of the index, or at the end character, that is at the last character, it is going to be what? It is going to be true. So this indicates that this current character is the end of this current string, right? So I hope that tries is being recalled here. Let's move on. So what we are going to do, we are going to just store this data, or we are going to just store all, yes, what we are going to do, yes, so what we are going to do, we are going to create a root node first, and then we are going to declare its child. First it is going to take which character? As we know that it is going to store in lexicographical order, that is from A to Z. First it is going to look that, let's see, first E is coming, therefore it is going to create a node with E, right? This E is going to store what? A, and it is going to store what? T. Now this T indicates that it is the end, right? Again it is going to look for another word, that is eat at. So this T is going to have one more child, that is going to be A, and it is going to have another child, that is going to be T, right? So this T indicates that it is also end of this string, right? So these two are already included. Here you can see that it is not going to create separate things for eat at. because first these three strings were already present for this e that, therefore it is going to use the same strings, right, same nodes. Now it is going to make next thing for what, for let's say oath. So it is going to create a node of o, a, t, h. This h is going to indicate that it is the end. Now it is going to create for what, it is going to create for p. So p, e, a. This a is nothing but end, and this is going to create another for rain. So r, a, I, n, and this n is telling that it is going to be the end, right? Now what we are going to do, next thing what we are going to do, we are going to start traversing in this array. We are going to start traversing in this array. That is, we'll be standing at o, and we'll be asking to our root node, that is to our trie data structure, that do you have any string present or any child present in you which is starting with o. Yes, there is a child that is starting with o, that is this point, right? So if it is present, it is going to make 4 calls, that is adjacent calls. These 2 calls are null. These 2 calls are out of board, therefore they are not going to make any sense. So only valid calls are going to be these 2, right? So it is after this making this call, that is after making call to a, it is going to ask to this, or let's say first let's see for the null case, or the invalid case. First it is going to, let's see, ask to this e, that is it is going to ask this root node, that do you have any string or any child who's for any child starting with o, and its child, or that child having another child starting with e. It is going to say no, I don't have that, so therefore there is also going to be invalid. Now it is going to come to a, it is going to ask that is there any string that is having a as the second character. So it says that yes, I do have a string that is having o and a, right? So from this a, it is going to make another 4 calls, right? From this a, it is going to make 4 calls. Now we are going to maintain a boolean array of visited, that is going to tell us that this o has been already visited, therefore it is not going to be stuck in infinite looping, right? Infinite calls. Therefore it is not, if it is a visited thing, visited cell, then it is not going to go back to this particular point, right? So it is going to check for this and this. Now from a, we are going to see that if there is a string which is having another a as a child, that is first a, then a, there is no string, it is then going to ask if there is a string which is having t as a child of a. So here there is a string which is having t as a child of a, right? T as a child of a. So from this t, we are going to make 4 calls, right? That is going to be here, 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 and above it is going to be visited, right? And similarly we are going to get a oath, that is the first letter, right? That is going to be from this point to this. If I clear this out, you'll be able to see that is going to be this thing, right? So actually after this, what we are going to do, we are going to just store this in our array, or let's say anywhere, we are going to just store this answer. And we are just doing what, actually we are doing what, we are just using the concept of recursion and backtracking. We are just going to backtrack, and we are going to end up to we are going to be back to we are going to be we are going to jump back to o. So calls for o is complete. Now we are going to look for a. So oath has been created. Now it is going to check for a. So now if we are not using this trie data structure, then what we would have did, we would have traveled from this position to this, or to all positions. But now instead of making calls, first we are going to check that if there is any string present with starting node as a. If there is no string present as a, or no node present, there is no node present as starting letter as a, then it is not going to check for that. It is just simply going to move on. It is just simply going to move on. Now it is going to check for this E, and it is again going to make this 4 calls. So the concept is really easy. So logic is that's it. The logic is going to be that's it only, that we are going to just ask every time to our root node that do you have any child like this or, or not, and we are just going to create our answers. There might be multiple answers, right? But now what we have to do, we have already seen that we cannot store this answer. Like for example, we cannot use this answer if there was there was something like this, there was two answers, something like this, eat, and there was another answer like this, eat at, eat at, then we would not be able to use this eat at or eat. We would be just storing this eat as our answer, right? So we have seen this in our question. So basically what we are actually doing, we are just doing what? We are just checking if a character exists as child of our root node. If it is true, right? If it is true, then do something, right? Then do what? Then just do, or let's say just check that if the root's child having some string is not empty, right? We are just going to check that if it is having some not empty string, and if the this is also true, then we are just going to call to our neighbors, right? And this, with this we are going to get our answers, right? So let's code this thing, and we are going to get a more insight of this question. Now here we will be provided with some functions. Let's complete these functions. So what is going to happen? First we need a node to traverse. Let's call it as root node is equals to new node, right? After that we have to do what? We have to create our tries. So for that, what we are going to do, we are going to iterate on strings, all this string from words, and we are going to insert this root with this respective string, right? So with this we know that we have to complete some insert function. So let's complete that insert function first. So what's this insert is going to do is this is going to just insert create a new node, and it is going to insert. So for int I is equals to 0, I is less than s dot size, I plus plus, right? It is going to remove one character, that is s dot at I. Now from here it is going to check if the current nodes, that is the current node's child is having that character or not. So it is going to check by ch minus a is equal to null. If it is null, then do what? Then create new node. Then create a new node with this value, that is going to be is equals to new node, and attach it to current child. Or instead, there is no need to attach for now. Let's just create a new node, and if it is already present, then just update it. So update it with the same string. Now string is also going to be updated. So current string is going to be updated with s, right? And with this our insert function is completed. Now we have to do what? We have to move forward. That is, we have to first travel to this whole board. So int, let's take a variable int n is equals to board dot size, and int m is equals to board of 0 dot size. we are going to create a vector to store the visited array. That is, it is going to be our boolean vector of visited array. So vector of bool, but it is going to be a vector of vector. So vector of bool type, that is going to be named as visited, and it is going to be of size what? N into m size. So vector of bool type, that is going to be of size m, right? And initially it is going to have all the false value. Then we need another vector of answer. So it is going to be a string answer, right? Now after this we are going to traverse to this whole array, that is to whole matrix. So int I is equals to 0, I is less than n, I plus plus, for int j is equals to 0, j is less than m, j plus plus. What we are going to do? We are going to call this DFS with board. Now we have to travel to those all four directions, right? So we are going to send board, our ith index, our jth index of the board, our answer, first our root, then our answer, then our visited array, and that's it, I guess. And after getting something from here, we have to just return our answer from this point, right? Now as we are calling this DFS, let's complete this DFS, right? So this DFS is not going to be new. It is just going to be something like we used to do previously in n queen problem, or let's say in knight 2 problem. The very initial step, or the very idle step, what we used to do, as we enter this function, we used to mark the current position as true, and we used to mark the same position after doing the work as false, right? Now here we have to make some calls. So let's make a call to DFS, and now we are going to make a call in which directions? In four directions. That is going to be this, 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 and this. What are these three directions, these four directions? It is going to be, if this is I comma j, it is going to be what? It is here I is getting I has been decreased, so it is going to be what? I minus 1. J as it is, it is going to be what? I as it is, j plus 1. It is going to be what? I as it is, j minus 1. And it is going to be what? I plus 1, and j as it is, right? These are going to be our four directions. So DFS to our board, I plus 1, j as it is. Then what we have to send? We have to send a root, but let's talk about that. Let's talk about this root again after some time. We have to pass here something. So let's for now pass this null, right? Then what we have to pass? We have to pass our answer, and we have to pass what? We have to pass our visited array, right? Similarly, there are going to be four calls. So I plus 1, j minus 1, I minus 1, j as it is, I as it is, and j plus 1, right? These are going to be the four calls. Now instead of this null pointer, what we are going to send? Sorry, we are going to create our answer, and that is going to be of what? That is going to be of nodes child, that is the current nodes child. So child LD, because we have to look for the current root nodes. That is going to be what? That is going to be this node, this root node. We have to check for its child. So for this node, its root node is going to be this E, not this starting node, right? We have seen this in our search, binary search operations and all, right? So what we are going to do, we are going to check that if root child having that character or not, that is board of I j minus a if the child string, that is child string length is not equal to, that is not equal to 0, or let's say null, or 0 only, because we are going comparing the length thing. Then do what? Here it is going to be, this means this means that our answer is created. So answer dot push back this string, so child str, make it an empty string, so it will give us new answer, or it will create a new string for us, and it is going to give us that answer. So child's str is equals to this empty string, right? Now with this it is done. Now what is going to be our base cases? First, our base case is going to be what? I is less than, if I is less than 0, it is out of board. J is less than 0, it is out of board. If my I is greater than board dot size, then it is out of board. And if my j is also greater than board of 0 dot size, it is out of board. And if my visited of ij is equal to true, that is it is already being visited, then don't visit there, right? These are going to be my base cases from where I have to return. And another base case is going to be what? If the current character doesn't exist in the root node, right? The current character is not existing for the root in the main node, right? So what we are going to do? We are going to, for example, that is nothing but if my current character, let's say this a is nowhere as a child of this main root node, right? As a child node of this main root node, right? So we are going to check for that thing. So k is equals to, let's call it as key is equals to sorry, board of ij minus a, right? And we are going to check if root child his key is equal to null, then return, right? So with this our function is almost complete. Let's try to run this and see if it is working properly or not. Okay, there are some errors. Line number 28, I is less than board. Here it is going to have this. Now let's run this code, and it is being rejected. There is some mistake. Oh yes, here we have to pass what? We have created this child, so we have to pass this child. So this child, see it, child d, child d. Now let's try to run this code, and it is giving us the correct answer. So with this, I hope the question and the solution is clear to you all, and this is the code. So thank you for this video. Let's meet in the next video.